Good morning all. This is Kavi Priya from SNS College of Allied Health Science, Department of Cardiac Technology. The lecture video is about autonomic regulation of heart rate. So here the introduction to heart rate regulations. The heart rate is a number of heartbeat per minute. The electrical activity of heart is about per minute. It is calculated per minute. That is 60 to 100 per minute at rest. It is normal for adult, and it is regulated by autonomic nervous system, which is balances our body functions. So autonomic regulations are comprised of sympathetic and parasympathetic branches. Here the diagrammatic representation of sympathetic and parasympathetic branches. See, the cardiovascular center is there, and it is axillary center. The right side one is a sympathetic and left one is a parasympathetic vasovagal tone nerve. And chemoreceptors, it is present in the aortic arch, and baroreceptors also present in descending aorta, and it is also get regulated by kidney for the pressure maintenance. So it is most important for the control of heart rate. Here the autonomic regulations, ANS, is involuntary functions, which is involuntary functions, and it maintain the heart rate and digestion. It is important in maintaining heart rate and digestion. So sympathetic nervous systems are fight or flight, which means during sleep the heart rate decreases, during the exercise or working metabolism get increases. Once the heart rate it also get increases. And parasympathetic nervous system, rest and digest. Sympathetic are fight or flight, so parasympathetic are rest and digest, so decreases in heart rate. Both system are interact to fine tune in a heart rate dynamically. So central control, there is a medulla oblongata presented in our brain, so which control the heart rate, maintain the normal regulations. Next one is sympathetic regulation. It is originated from thoracic spinal cord from T1 to T6, and it is pathways about cardiac nerves to sinoatrial node, SA node, AV node, bundle of gas, Purkinje fiber, so sinoatrial node. And neurotransmitters are norepinephrine. So its effect is about increases the heart rate. Once the heart rate get increases, the contractility of left ventricle also become increases. So it is originated from T1 to T6, and it is pathway is about SA node, and neurotransmitter is about norepinephrine. Norepinephrine which get increases the heart rate and contractility also. For example, heart rate rises during exercise and also stress, anxiety, etc. So the receptors are beta adrenergic receptors on the cardiac cells. See, this is the increases in heart rate, PNS, SNS, equilibrium, and once the heart rate increases and decreases. Stress which get increases, downstage which get decreases, and restoration. And parasympathetic regulation. Here the parasympathetic regulation, it is originated from vagus nerve, cranial nerve, 10th cranial nerve. So it is pathway is about vagal fibers to SA node, sympathetic action from SA node also, and here also vagus nerve to SA node and AV node. The neurotransmitters are acetylcholine. Acetylcholine once decreases the heart rate, promote ventricular muscles or ventricles get cells get relaxation. That is repolarization and depolarization. Once the sympathetic nerve get repolarize the heart muscles, depolarize the heart muscles, and parasympathetic nerves get relax the cardiac muscles. So examples are slow in heart rate during the rest or sleep. The receptors are muscarinic cholinergic receptors. A neural control are medulla oblongata. It is a primary control center, and cardiac acceleratory centers also. It is activate the sympathetic output. So cardio inhibitory centers are enhance the parasympathetic output. So input are baroreceptors and chemoreceptors, which is higher center in brain. Examples are hypothalamus. So it is the loops are maintained in heart rate balances. So once the baroreceptors are pressure sensors, it present in carotid and aortic arch. So it detects the blood pressure. Once the pressure get increases, it start to decrease the heart rate. Okay, so increased in parasympathetic action, so activity in medulla oblongata get lower the heart rate, and in low BP increases the sympathetic action activity, so higher the heart rate. It is a rapid response to maintain the cardiovascular stability. So note the include graph showing BP changes and heart rate explain about reflex present in our already were given in a chart which will maintain the heart rate. So this one, parasympathetic and sympathetic tone. So here the ANS regulate the heart rate via sympathetic and parasympathetic actions, which is medulla oblongata integrate the sensory input, and baroreceptors, chemoreceptors are provide the feedback. So balance ensure the cardiovascular hemostasis, and dysregulations has significant clinical impactions. And clinical relevance are dysregulations means linked to hypertension, arrhythmias, heart failure. So the drugs are beta blockers, atropine, sympathetic and parasympathetic. Vasovagal stimulations are therapy for heart rate conditions, and mainly in exercise, which enhance the parasympathetic action over the time. So there is also stress, which is chronic sympathetic activation, which is harms to the heart health. Thank you all.